day. Hey, thanks for having me. My name is Will. I'm here to talk about 0x, protocol for trading tokens. To lead in, just tell you a little bit about ourselves. This project's been in the works for almost a year now, and along the way we've kind of put together a really great team of developers and investors and partners. And actually today is the very first day all 5 of us on the team are going to be in the same place at the same time. So Fabio and Leo are both from Europe. Amir and I are in San Francisco, and Alex just joined last week. He's also in San Francisco. And I believe Leo actually just touched down. He flew here from Warsaw, and he'll be here in a couple minutes with his suitcase. So keep your eyes peeled. A brief overview. I'm going to provide a little bit of motivation for 0x and why we spent all this today. Go through all of the existing work that motivated the design decisions that we've made. Then I'll kind of provide a high-level overview of 0x, how it works, and then get a little bit deeper into the technical details. We'll talk about 0x OTC, which we released about a month ago. It's the very first user-facing product that allows you to actually use 0x today. It's just a web app. And then I'll talk a little bit about our timeline, the milestones that we've hit along the way until this point, and our plans for the future. So the world is becoming tokenized. In the brief history that Ethereum has existed, there's already been a rapid accumulation of ERC20 tokens that have sort of found their way onto the Ethereum blockchain. Today there's around 20 to 30 different Ethereum tokens. Most of them were sort of released blockchain, an ICO or a token launch process, and their combined market cap is over $2 billion. There's also around 100 different decentralized applications that exist today. But we're just getting started. So in our view, by 2020, there will be many thousands of digital assets on the Ethereum blockchain. And these will represent things like traditional securities, stocks and bonds, to fiat currencies, all the way to like scarce digital goods, like airline miles, loyalty points, video game items. These are just massive industries that will be tokenized and moved onto the Ethereum blockchain. And we believe that the combined value of all these tokens will be in the tens to hundreds of billions of dollars. There will also be thousands of decentralized applications, many of which will have their own token. And naturally, this token economy will need a in order to tokens. So just kind of covering the current ecosystem of exchange on the Ethereum blockchain. There's already a handful of decentralized exchanges that exist today. And there's also a bunch of different decentralized applications that require exchange functionality in order to operate. For example, prediction markets, decentralized asset management platforms, decentralized stablecoins, and what Nadav presented, Dharma, is going to need a way for liquid markets to develop. The issue with the current ecosystem is that each one of these existing projects is creating their own custom and proprietary smart contracts for exchange from scratch. And this is a problem for a variety of different reasons. First and foremost, there's no interoperability between any of these exchanges. So it kind of fragments the liquidity pool, and it results in very little and be developing on any of these platforms. For the end user, this poses a problem because each smart contract has different levels of security and efficiency. Each contract has a different learning curve and configuration process, and they essentially have to trust 20 different smart contracts that do exactly the same thing. So this creates kind of a large attack surface for your valuable digital assets that you want to exchange. So our thesis is that smart contracts should act as modular, unopinionated building blocks that can be assembled and reconfigured. And we also believe that open standards tend to win out in the long run. So existing work. The very first decentralized exchanges that were built on the Ethereum blockchain, they kind of took the functionality of a traditional centralized exchange and pulled it into a contract, Ethereum smart contract. And so what these exchanges looked like were essentially order books that were stored within an Ethereum smart contract, sort of recording the buy and sell interest for a given market and at given prices. And Maker Market, you can go and use it today. It's been rebranded to Oasis Dex, as well as the very first exchange implementation used in Augur will use these on-chain order books. So the issue with on-chain order books is that since the order book is stored within an Ethereum smart contract, every time you want to post, edit, or cancel an order, you have to store a bunch of new data on the Ethereum blockchain, and you have to pay gas costs for that transaction. So this means it's completely prohibitively expensive for any sort of market maker to create liquid markets, because they have to pay tons of ether and gas costs. Floats every time they need to adjust their orders in sort of a reaction to the market. Another downside to the on-chain order book is that it bloats the Ethereum blockchain. Every time you say, if you have an order for some trading pair at some exchange rate and you want to sort of adjust the exchange rate slightly because the market has moved, well, guess what? Thousands of computers all over the world are going to have to record the fact that you have slightly adjusted your order in perpetuity forever, which is a really inefficient way of using a blockchain. The third downside to these on-chain order books is that they're really high latency. So not only does it take at least one full block time to post an order, but it also takes a full block time to modify or cancel an order as well as settle an order. So on-chain order books were kind of the very first iteration of decentralized, but we kind of saw very quickly that they're completely infeasible for any sort of truly liquid markets. The second type of decentralized exchange that people really explored was the automated market maker. And how the automated market maker works is that instead of two counterparties on opposite sides of the market trading directly with each other, each party trades with a smart contract, and the spot price offered by that smart contract responds deterministically to buying and selling pressure. So there's actually a mathematical relationship that says if you sell X, the price will respond with Y. Now, say if there's pricing models have plenty of issues if you look in the literature. If you're trading in a very thin market versus a very thick market where there's tons of volume, prices will respond in the exact same way. So essentially you're kind of placing a constraint on the supply side, or sort of on the supply curve. So it's not a very economically efficient model. The second issue is that if you have a huge chunk, say if there's two parties on each side of the market, and they each have sort of a huge chunk of tokens that they want to trade with the counterparty, they actually can't just do a trade directly with each other and settle the trade. In effect, each party has to chop up their big chunk of tokens into these small little units, trade it with the automated market maker, and they each have to go back and forth trading these small little chunks. So it really kind of puts there's large constraints on the throughput that automated market makers can offer. The third issue is deterministic, and you know exactly how the price will respond if you buy or sell some sort of asset. If someone else sees that you're making a trade because your transaction is pending in the pending transaction pool, someone can very easily go and make that same trade, but with a higher gas price, and they can essentially front run your order, which is really bad. So Augur and Gnosis, they're both decentralized applications for prediction markets. They both sort of started out attempting to build a automated market maker for their markets. They both kind of discovered these problems independently, and they both sort of abandoned this idea. Gnosis wrote a really great blog post about automated market makers, and what they did find is that the automated market makers are great for something, and that is on-chain price market making in terms of moving moving sort of resources or assets between different parties, but they're very good at sort of providing an on-chain spot price that other smart contracts can look at. So Bancor is also, I don't know, has anyone here heard of Bancor? Okay. So Bancor is a type of automated market maker smart contract. It's slightly more complex in that it's not a single market that a smart contract is trading on. If you trade on one market, it can, in effect, sort of affect the prices of other unrelated markets. So it's a little more sophisticated. It's a very ambitious project. We'll see if it ends up working out. So the third class of decentralized exchanges that we'll probably see very soon are exchanges based on state channels. And state channels are a very exciting piece of technology. So a state channel essentially allows you to lock up some funds, do a bunch of sort of intermediate state changes off of the blockchain, and once you're sort of done doing these state changes off of the blockchain, you accumulate them together and you settle them on-chain in a single transaction. So it's very efficient for some use cases like day trading or sort of like any bar tab-like application. Another example might be like poker. You take your asset that you want to bring to the poker table, you lock it up and you go sit down, you play a bunch of different hands of poker, and once you're sort of done playing, you can kind of move your the final state of that poker table. You can kind of move that back on chain, and it's a single transaction instead of requiring a transaction for each hand of poker. So it's much more efficient. If you what's also really interesting about state channels is that they're very low latency and high throughput because they're not constrained by sort of the performance of the Ethereum blockchain. So this will be really good for things like high frequency trading, for example. Now, there are some things with state channels that make them not all that great for certain sort of use cases of trading. For example, if you just want to sell 100 reputation tokens in a single block trade, a state channel is probably a much less efficient way of doing this trade than, say, for example, 0x, which we will go into later. And the reason why it might not be very efficient with the state channel is because there's quite a bit of overhead associated with opening the state channel, closing the state channel, and making sure that all the parties that were involved in the state channel behaved honestly. So you're required to, you want to 2 to 3 or even more transactions in order to open and close a state channel. There's a security deposit that each party has to kind of place into the channel to sort of ensure everyone's behaving honestly. And then when you're attempting to close the state channel, there's a challenge period, which is sort of another measure that's required to ensure that each party in the state channel is not cheating. So in effect, you want to just dump some tokens, but you're required to make multiple on-chain transactions to do this, and there's quite a bit of time involved as well. So I would say like the other really big limitation of state channels is that since all of the channel is completely isolated from the Ethereum blockchain, essentially assets that are locked in the state channel cannot interact with smart contracts on the Ethereum blockchain at all. So all of that sort of awesome logic that is encoded within a smart contract, you can't access that when you're in a state channel. So how does 0x work? 0x uses something called off-chain order relay with on-chain settlement. And there's a couple other projects that figured out this approach around the same time that we did. One of them is Ether Delta, which is live and you can go use it. Has anyone here used Ether Delta? Yeah. Okay. So there's actually Ether Delta is one of the first sort of decentralized exchanges to be put into production, and it actually sees like a decent amount of volume every day. And Ether Delta uses the same approach. Another is IDEX. So with off-chain order relay and on-chain settlement, essentially what you do is you specify the parameters associated with the order that you want to place. Say, I want to exchange these two assets at this exchange rate, and I'm willing to honor this order until T time. Well, you essentially take all these parameters, you place them together, you concatenate them, and then you cryptographically sign them with your private key. And then you take these parameters, you take the signature, and you broadcast them to your counterparty. And what your counterparty has is essentially proof that the person honor this order that you have created. So this diagram kind of shows the process. There's a smart contract. Both people on either side of the trade provide access to their tokens to this smart contract. They're comfortable doing this because the smart contract is open source. You can read through the source code and you know exactly what the smart contract's capable of doing. The person, the maker, creates this order. It's just a data packet, just chunks of data that describe the order. They cryptographically sign it with their private key, and then they broadcast this data packet to their counterparty. And it really, since it's just data, it doesn't really matter how you broadcast an order party. You can send someone a 0x order over Facebook or email. You can take an order that's cryptographically signed and you can broadcast it on Twitter. And anyone that sees this order can then inject it into the smart contract, and the smart contract will authenticate the cryptographic signature. It'll make sure that each party has sufficient a sufficient balance of tokens in order to execute the trade. And then the smart contract, assuming all of the conditions are met, will sort of do this settlement of funds. Yes?
So don't make me feel long answer, just tell me to shut up. But so you said that you create the order off-chain.
Yes.
But you do need to secure the assets somehow on-chain while the order is pending, no? So to do settlement, when you do settlement, you do the trade, the contract has to check, do both of these users have the funds have been secured on the contract during order creation, yes or no?
So the question is, do you need to lock up your funds in the same way you do when you open a state channel? And the answer is that you can do that. It depends if you want to sort of create a smart contract that secures the funds, but it's not a requirement. So
what if I just spam your order book with like 1,000 offers that I have no intention of keeping, and I don't actually have any of the tokens that I'm offering up in that trade?
Right. So I mean, so essentially, how do you prevent someone from generating a bunch of orders that they can't actually fulfill? So that's a very easy problem. You just look at the blockchain and you see they don't have this order, so I'm not even going to begin to put it into my order book. So it's actually not that hard of a problem to solve. And actually, we can talk about this later once we get sort of into the question section. But it's a question that has pretty easy solutions. So actually, before we move on, were there any other questions about how this this process works?
Well, what exactly is the connection to Ether Delta? Are you saying that you made that or
No.
It's using a similar scheme?
It's using a similar scheme where orders are sort of broadcast off-chain and then injected into the blockchain to settle a trade. Yes.
Is there any guarantee that I can see all the orders in the network?
It depends which sort of network transport layer you're using. So, if you and I wanted to do a private trade without anyone else being involved, I could generate this order, I could cryptographically sign it, and I could send it to you in like a private email, and no one else would know about it. An alternative approach to take this data packet and put it into an order book that is publicly accessible. Yes?
Were you envisioning a price mechanism? I didn't quite catch how that would work, the previous mechanism to display the price.
Right, so the price information is actually contained within the order data packet that you're signing.
So people after, I guess of course you can scour you just got to scour all the orders and just what's happening.
Well, it really depends. Yeah. So actually, this is something that we're going to talk about in depth later in the presentation. So why don't we one more question?
Is this token to token or token to fiat or both?
So this is this protocol supports ERC20 token to ERC20 token. So right now there's 20 or 30 ERC20 tokens, there, etc. Great. So 0x is essentially a message format and a system of smart contracts that accepts data packets that conform to this message format. And the message format is shown here. There is sort of all the parameters that kind of lay out the exchange rate and the trading pair, as well as the person that's originating the order. And then there's room for sort of fees, which we'll get into in a bit. And then the last sort of chunk of data on this data packet is a cryptographic signature. So all of this is sort of bundled up, and this is a sort of a single order that you can then send to a counterparty. So one thing that's really unique about zero the plat, there's currently nothing else out there that allows this type of thing, is that 0x is it's open source, it's publicly accessible, and it's non-rent seeking. So it's not like us, the development team, it's not like we're operating in exchange and collecting transaction fees for it. Instead, we're creating the platform that anyone in the world can use to create their own exchange, and they collect transaction fees for it. They retain 100% of the transaction fees that they generate, and it's an open system. So relayers play a critical role in this system. A relayer is essentially any party that collects these cryptographically signed data packets and probably sort of arranges them and organizes them and presents them to a network of users that are interested in executing trades. And the person that is sort of presenting this off-chain order book is able to charge transaction fees for this service. And so this diagram kind of shows the process that allows a relayer to charge transaction fees and ensure that they are in fact getting paid a transaction fee for each order in their order book. First, someone that wants to generate an order, the maker, they go to the website or whatever it may be. It's probably going to be a website that the relayer is operating, and they say, I want to place an order on your order book. The relayer says, welcome. This is my fee schedule. If you want to place an order with these parameters, then you must give me a fee of X amount. The maker, if the fee schedule is satisfactory to them, will generate an order. They will the fees that's within the order. They will cryptographically sign it, and then they will send it back to the relayer. The relayer checks to see that they're receiving the fees that they're requiring. They check to see that each party, or essentially they check to see that the maker has a sufficient balance of tokens to honor that order. They check to see that the cryptographic signature is in fact authentic, and then upon all of these conditions being satisfied, the relayer adds this order to their order book, which is then sent out to the world of people that are trading. So, single line of, this is probably like the most powerful part of 0x that I'm really excited about, and it goes a little bit beyond sort of just traditional exchange, moving assets between different parties. And what's really cool is that 0x allows any smart contract on the Ethereum blockchain to programmatically execute trades in a single line of Solidity code. So what this means is that any dApp or system of smart contracts can sort of do much more sophisticated things than was possible before. Another thing that's really cool is that if you're operating a relayer and collecting transaction fees, any dApp that is pulling liquidity and executing trades is another customer for you. So it sort of generates these network effects around liquidity that you don't see for any sort of other exchange that exists today. So this is sort of the long-term exciting point, is that once you have given smart contracts the capability of executing trades programmatically, then you can start to see these really sophisticated decentralized applications start to take shape. So any sort of sophisticated decentralized application will likely need to interact with sort of different networks, and there will be different layers in this stack. There will be requirements for decentralized storage. There will be requirements for decentralized computation. There might be a need for sort of dispatching requests to other networks. And all of these different functionalities will need to be layered on top of one another to kind of create a unified application experience. And so the issue with this current idea and sort of if there is going to be decentralized applications that require a bunch of different tokens in order to operate, the problem is that not everyone wants to hold on to 10 or 20 tokens. Not everyone wants to be holding these volatile assets that they don't necessarily have like a stake in. They just need it in, like temporarily to access some form of functionality on the decentralized web. So what 0x allows is something called token abstraction. So instead of having to hold on to all of these different tokens with different properties, if you're an end user of a decentralized application, you can the smart. So if you're based in the US, maybe you just have USD tokens. You send these USD tokens to a system of smart contracts. It purchases synchronously and within a single transaction. It purchases some of these 0x tokens, which are needed in order to sort of execute trades with relayers. Then with immediately after, the smart contract can go and it can batch fill multiple orders. So it can pull orders from different relayers to get these different tokens, and it can then essentially use these different tokens to kind of power the different subsystems of the decentralized application. So underneath the surface, there's sort of all of these different ecosystems that are being interacted with, but for one user, they don't really care and they don't know. All they know is that they're spending some USD to use this dApp, a couple dollars maybe. So this will be, we think this will be a really powerful capability that will lead to more sophisticated dApps in the future.
Do you actually have like a fiat interface, or is that just hypothetical?
So we know of one that's coming out, but it's not released yet. So this comes to the 0x token. So 0x token is used for two primary reasons within 0x network. First, 0x token is used to incentivize relayers to maintain these off-chain order books. So in much the same way that on a proof of work blockchain like Bitcoin or Ethereum, you need a sort of a mining subsidy and transaction fees that incentivize miners to kind of secure this decentralized peer-to-peer network. In 0x, you're using these 0x tokens to incentivize relayers to host and maintain these off-chain order books. The second and more important use case for the 0x token is for decentralized governance. So 0x is a system of smart contracts that lives on the Ethereum blockchain, and the Ethereum blockchain is rapidly evolving. So not only at the protocol level, Ethereum blockchain is moving from proof of work to proof of stake, but also at the EVM and the smart contract programming language level. Find a sort of pull new features and upgrade itself over time. Essentially, each exchange will find a reason to kind of fork off and add a new feature. And what will end up happening is that all of these network effects that are created when every exchange is speaking the same language will slowly be fragmented, and we'll kind of end up right where we are today, where there's a bunch of different exchanges and very little liquidity. So to talk a little bit more about how decentralized governance works, 0x basically has two primary modules. There is the exchange smart contract, and this module contains all the business logic associated with accepting orders that conform to the 0x message format, authenticating signatures, checking that each party has a sufficient balance of tokens to execute a trade, ensuring that each order is not decentralized. Generally, this is where all the business logic associated with exchange is stored. And this is the logic that will probably need to be upgraded and improved over time as there are new capabilities that are kind of built into the Ethereum blockchain. And then there's a second module, and this module is used for decentralized governance. And the decentralized governance module, essentially what it does is it provides people that own 0x tokens, people that have built profitable businesses on top of 0x. It provides them with a way of participating in governance and allowing the exchange module to be swapped out for a brand new smart contract if it's necessary and if all the stakeholders agree that it's a necessary update. And essentially what this does is it allows this system of smart contracts to be upgraded, secured through like a soft fork rather than a hard fork, where the entire network is disrupted, all of these off-chain order books immediately sort of become invalidated, there's all these failed transactions. Essentially, we can slowly transition the network of relayers and dApps onto a new exchange smart contract, deprecate the old one, and this whole process is secured through decentralized governance. So we just released 0x OTC about a month ago. And what's really exciting, so first of all, 0x is not at the concept stage. It is fully functional. It's running right now on the Ethereum Kovan network, and you can go try it out today. 0x OTC is just a web app that we released about a month ago. It allows you to generate an order that conforms with 0x message format, which you can see here. This is what's going on. Someone's selecting an expiration. They're taking this data packet, they're cryptographically signing it using MetaMask. They end up with this data packet here, which is the 0x order. And then what they're doing is they're broadcasting this order out to the world on Twitter. Anyone that sees this tweet can then go and click on it and execute a trade trustlessly with the person that generated the order. On the next slide, you can kind of see the other side of it. Actually, you can't. OK, the GIF is not working, I guess. But what this slide typically shows is someone receives an email, and the email contains an order. They plug it into 0x OTC, and they execute a private over-the-counter trade. So timeline and roadmap. Amir and I began working back in October. We released our white paper in February. We deployed our contracts to Kovan back in March. When we launched OTC in May, around the time Fabio joined. Just a couple weeks ago, actually, we quietly open sourced 0x.js, which is a JavaScript library that allows anyone in the world to create a relayer and start essentially hosting and maintaining an order book and charging transaction fees. And it's just a JavaScript library. You don't have to be an Ethereum expert. You can include this JavaScript library in your project, and you can get started developing trades. We are in the process of going through security audits for our smart contracts, and immediately after, we're going to be deploying them to the mainnet, and people will be able to execute trustless trades on the blockchain immediately thereafter. So August 15th, this is the first time we're announcing it in public. August 15th, we're going to be doing our token distribution event, and 100% of the money we raise is going to go back into developing open source software, tools, and infrastructure that supports 0x protocol and the ecosystem that forms around it. And then we have a long development roadmap that's available online. I encourage you to go check it out and learn more about our project. You can find out a lot more about 0x at our website at 0xproject.com. You can keep up to date with our development on Twitter, Slack, and GitHub. Everything's open source and forkable. You can take it and build on top of it, whatever you want. So thank you for your attention. I appreciate it, and I'm here to take questions. Yeah, so, okay,